All right, we're going to take review day 14, problems 1 through 5, and the first one is maybe the hardest of them. We were given this here, and we were told that this balloon is rising at a rate of 2 feet per second. So we'll call this value x. dx dt is 2 feet per second. And they want to know at how fast is this angle changing at the moment that it's 40 feet above the ground. So first off, we need an equation that relates all of this together. So if I have this as theta, this is opposite, this is adjacent, so I'm going to use tangent. So the tangent of theta is equal to x over 30. And because 30 is not going to change, I don't need to make it a variable for this. I'll just leave it like that. Now, we're going to take the derivative of this. So the derivative of tangent is secant squared theta times d theta dt because of the chain rule equals, and it helps to see this as 1/30th times x, because then when you do the derivative, it'll be 1/30th times dx dt. All right, if I were to multiply by secant or divide by secant squared, I'll have this over secant squared, and using a little bit of trigonometry, if I have 1 over secant squared, that's the same as cosine squared. All right, so d theta dt is 1/30th times dx dt times the cosine squared. So I got a little bit of work to do. This is 40 in that moment. So you can kind of see 3, 4, 5 taking shape. It's 30, 40, 50. You can do those in those multiples. It saves you a little bit of time there. The cosine would be adjacent over hypotenuse. So the cosine of theta is 30/50ths or 3/5. So then the cosine squared would be 3/5 squared, which is 9/25. All right, let's put it all together. D theta dt is equal to 1/30th times dx dt, which is 2, times 9/25. So this is going to give us, if I do a little bit of simplifying, I can knock that to 10 and 3, and I can knock this down to 1 and 5. So I get 1 times 1 times 3 over 5 times 25. I end up with 3 over 125, which is B. You could just multiply it all and then simplify. I like to kind of do it this way. Tough problem for sure. This is not obvious, and a lot of work involved in that, but that's how you do that one. Okay. Second one says, how many vertical asymptotes would this graph have? Now, a vertical asymptote is when you have a factor in the bottom that doesn't cancel. So if we were to factor, we're going to have x minus 2 over x squared plus 4 and x squared minus 4. Okay, now x squared plus 4 won't equal 0. X squared is always positive. Adding 4 won't make it turn to 0. So we really don't have to even worry about this factor necessarily. X squared minus 4, however, does factor into x plus 2, x minus 2. Okay, so this cancels. That makes that a whole. That makes that a removable discontinuity. That means we're only going to have one vertical asymptote, and that's at x equal -2. So out of all of that, only one of them will be the vertical asymptote. Now we get here, and this one is rather strange. We try to give you a video that tries to help explain this a little bit. It's a topic that wasn't on the AP for a long time, then all of a sudden they brought it back a couple of years ago. Would it be on your short version? I would probably bet no, but if you want to play it safe, here's the deal. We know what this represents. We've got x squared from 1 to some value b, and we're trying to figure out what that b could be. And it says if that equals this, and that looks very strange, what could the be? Now here, I'm going to try to make it real simple. What they're doing here is they're taking this, which you can kind of see as like the x squared, right? So this would be like the heights of the rectangles. All right, and this 2 over n, those would be the width. So what they're basically saying is let's take, you know, these rectangles here, and let's split them into n number of rectangles. So here's the key. Obviously, they're letting n go to infinity. They're trying to put an infinite number of rectangles in there. But what did they split into n sub-rectangles? And that's 2. 2 is the distance between your endpoints. Meaning that they're taking this whole gap here and dividing it into n subintervals. This gap right here is 2. So if I started at 1 and I go 2, that means I must be at 3. All right, so again, not something to get too hung up on. I think that's the best thing to kind of remember, is that whatever you see here, that's how far away you are. And that'll be one of your spots. That'll be your starter spot. And then add that on, that'll give you your n. But again, I wouldn't lose any sleep over that. The next one, my printer decided to be kind of a pain on me here, so we'll kind of fit it together. It's not a hard problem, but for my printer, it ended up being. So it says the function f is continuous. This is f prime. When is f increasing? So we know f is increasing when f prime is positive. This is f prime. It's positive from 0 to 2 and from 4 to 5. So 0 to 2, 4 to 5 was D. Don't know why my printer needed 3 pages to tell us that, but that's how it was. All right, and then we get to our last one for these this section. It says the height of an object is given by this. What is the velocity at time 3? So this is a simple enough problem. We're taking the derivative with respect to time. Now this was on the calculator section, so I would just plug that into your calculator and go h prime 3. And if you did that, you should have gotten B 7.778. All right, simple enough. Throw it on the calculator and get your answer from there.